On 9.4, we are combining a bunch of information that we have already done, basically. We're multiplying and dividing rational expressions. I'm not actually going to write that out. Today we're just going to do the multiplying part, and then tomorrow we'll do the dividing part. Okay. Now there's a lot of different things here at the beginning that they're talking about. Basically, it's all talking about getting things in simplified form. Simplified form just means the smallest form, right? Like it's simplified. I don't know how else to put that. Okay, so what we're going to do first on our first example is we are going to take this expression and just simplify it for them. So I have x squared minus 4x minus 12 divided by x squared minus 4. You are going to have to be able to factor. Okay, if you can't factor, you're going to struggle here. Okay, so if you don't know how to factor, you're going to have to learn very quickly. And I would also like to know how you got through an entire chapter of factoring. Okay, so hopefully it's just going to take a little refresher here. So when looking at this to simplify, what do I need to ask myself to factor the top? What multiplies to negative 12 adds to negative 4? Negative 6 and positive 2. So my factors are x minus 6, x plus 2, correct? Okay, now I need to do the same thing to the bottom. What is special about this? They're both perfect squares. So what's that? What's this whole thing called? Difference of two squares. What's it factored to? And what? Okay. So now that I have everything broken down, okay, everything's factored out. Now to reduce it or simplify it, I can just cancel things out that are the same. Okay, those are the same, so they cancel out. I'm left with x minus 6 divided by x minus 2. And I'm done. Okay. Now I did have some people in my other class say, well, can't I reduce the 6 and 2 and the x's cancel? That doesn't work. Because x minus 6 is one term. If you knew what x was, hey, you plug it in and you get one number, right? That's one term. Okay, so don't cancel things out individually out of here. If you can take it out of both of them, from the x and the negative 6, then you're okay. But if not, then you're done. Okay. We're going to do one more of those, and then after that, we're only going to do one example out of each one of the examples in the book. We're going to do two off example 1, though. X squared minus 5x minus 6 over x squared minus 1. Okay. What multiplies to negative 6 adds to negative 5? Negative 6, positive 1. So I have x minus 6, x plus 1. On the bottom, this factors to x plus 1, x minus 1, because it's a difference of two squares. Okay, and then my plus 1's cancel, and I get x minus 6 over x minus 1. And we're fully simplified at that point. What's that? Okay. Now, taking a look at example 2. Okay, it's progressively going to get a little bit more challenging as we go through these. Example 2, I'm not going to do the one you have in your book. I'll do a different one. I have 6x squared y cubed over 2x squared y squared times 10x cubed y to the fourth divided by 18y squared. They want us to multiply these together and then leave it as an answer in simplest form. So basically simplify it and reduce it. Okay. What I would suggest to you is simplify each of these individually first. Okay, that seems to make it easier for me anyways. There's a lot of ways you can do this. Okay, but personally I like to do that. So 6 over 2 reduces to 3 over 1. X squared over x squared cancels. Y cubed over y squared, y. Times 10 over 18 reduces to 5 over 9. X cubed over no x's, x cubed. Y to the fourth over y squared on top. Okay. Now you're just multiplying two fractions. Okay, so in the last class we like to cross reduce because that makes things even easier. Okay, so I take my 9 and my 3 and I change it to a 3 and a 1. Does everybody see what I did there? Since we're multiplying, we can cross reduce. Well, 1 times 5 is, on the bottom, 1 times 3 is, back to the top, I have y times y squared, which is y to the third. Do I have anything left over here I need to use? My x. I still need my x to the third. Anything else I can do down here? No. Okay, again, we've done all those properties. Okay, you were using your properties of exponents there. We knew we were dividing, so we'd subtract. We knew when we multiplied, we added our exponents. Okay, so just use those properties and combine those through multiplication. And most people didn't struggle with that. It's examples 3 and 4 that got difficult for us. So, on example 3, and they're pretty similar. There's a little different things in each. I have 3x minus 27x cubed divided by 3x squared minus 2x minus 1 times 3x squared minus 4x plus 1 divided by 3x. Now, if you really, really wanted to, you could take this and FOIL it into that. But then you're going to have to factor it out anyways. Okay? So we want to go back to what we did on the very first problem. We want to factor everything out first and then see what we can cancel. Okay? Because there's going to probably be some things that can cancel. Excuse me. So, looking here, is this factorable? What can I take out of both of these? And x. So let's take out our 3x, and I'm left with 1 minus 9x squared. Okay. Over, now I come to this. Okay, this is factorable. We got to remember how to do it. I could take a 3 out if possible, but I need to multiply so I get negative 3. So what multiplies to negative 3 adds to negative 2? Negative 3, positive 1. So now I'm doing it by grouping. So I have 3x squared minus 3x plus x minus 1. Group them. What can I take out here? 3x. And I have x minus 1. What can I take out of there? A 1. You got to take something out. If it's just a 1, that's fine. Okay, so then these two go together, and I get 3x plus 1 times x minus 1. Okay, so now I have this. Okay, times, on the bottom I know I'm just going to have 3x, so I'm just going to write that real quick. I have to do the same stuff here, right? Okay, so what multiplies to 3 adds to negative 4? Negative 3 and negative 1. So I have 3x squared, and I'm going to erase this in a second, minus 3x minus x plus 1. Group them. Take out a 3x. X minus 1. Take out a negative 1. X minus 1. So here I actually have 3x minus 1 from here and x minus 1 from there. What's that? Disgusting. Okay. Now, I'm not fully factored yet. Where am I not fully factored at? I'm not fully factored yet. Did I? Okay, I can reduce. I'm not fully factored yet, though. That's a difference of 2 squares. So it's going to be 1 minus 3x and 1 plus 3x. Okay. So my 3x cancels, right? My x minus 1 cancels. Now you got to look here. 3x plus 1 and 1 plus 3x. Aren't those the same thing? Okay. Now the bottom's completely gone, so you're obviously done canceling, right? Okay, so your final answer, and we're going to actually change it here in a second. We would like to write this with the 3x in front, because that looks weird. So it's actually negative 3x plus 1 times 3x minus 1. Hey, nope, we'll leave it simplified. Now, your book's going to give it to you a little bit different than that. What your book does is they then go ahead, they don't like the negative there, so they take out the negative. So now it's 3x minus 1 and 3x minus 1, so they leave it as negative 3x minus 1 squared. So they took out this negative here and a negative here and switched the signs. Okay. Again, there's a ton of stuff going on there. All of it we've done. Now we're just combining a bunch of stuff together with multiplication and factoring in your exponents. Okay. I have one more example here, and then I'll let you guys try some on your own. X plus 2 divided by 27x cubed plus 8 times 9x squared minus 6x plus 4. I like parentheses around all my stuff. Because it shows me what goes together easier. If you want to, you could write this over 1, right? Okay, some people like to see that it's a fraction times a fraction. Hey, some of you I know don't care. Whatever your preference is. Okay, so start on the top left. Can I factor that? Nope. So I'm going to leave it as x plus 2. Can I factor this? Well, let's try. Is there anything that multiplies to 36 and adds to negative 6? Anybody think of anything? So 6 and 6 goes to 36, but it can't add to negative 6, right? 9 and 4, but that doesn't add to negative 6. 36 and 1, that doesn't work. 18 and 2, that doesn't work. Is there anything? No. So that's not factorable. So I still have 9x squared minus 6x plus 4 over here. One's obviously not. Now I have to factor this. Anybody recognize this as anything special? Those are perfect cubes. So this is the sum of two cubes. This has a special formula. It does. Okay? I did put them right here. You're going to need to know them, though. It might be on your note cards. There's a possibility of that. Okay? So, what is A here? No, it's 3 something, but it's not just 3. It's 3x. It's this whole thing. So A is 3x. B is 2. It's the cubed root of both of those. Okay? Since this is plus, it's going to be A plus B, so it's 3x plus 2, times, now it's A squared, which is minus AB plus B squared. Okay. Does anything cancel? So on top, my final is, and on bottom, my final is. Okay. You are going to have to know your sum and difference of two cubes over here, though. You're going to have to know those. Okay, because you will use those. I'm going to for now, but then I'm going to erase them. Probably after today, I'll erase those. You guys are capable of writing. I know a lot of you sat there and didn't take a single note, but that's your choice, not mine. You can write things down. If it's the sum, you start with plus. If it's a difference, you start with a subtraction. Whatever sign is in your original is what you start with. I'd like you to know those for now, since this is the second time we've came back to them. Alright, for tomorrow, this is what I need, please. It's online. Are you not going to be here? You're not going to be here tomorrow?
So we all have an assignment tomorrow?
Yeah. Who's going to be here? Or excuse me, who's not going to be here? We'll see.